Okay, we're going to do some derivatives by the rule today. A bit more Unit 2 revision questions. So first one, nice and easy polynomial. So we're bringing down that 3. So we get 9x, and then we are subtracting 1 from the power, 9x squared. And then here we've got a 2. The 4 becomes 0, so our answer is 9x squared minus 2. Next one we have, obviously our 2 is going to go to 0, so we're going to focus on here, which is our chain rule. So we're going to write that we have 3u squared. So that's our f of x, or our y. So then dy on du is going to equal 6u. Now our u is equal to x plus 2. So our du on dx is going to equal 1. So then our dy on dx is going to equal dy on du times du on dx. So then we will bring that 6u and we're going to multiply it by 1. So we just get 6u. And then we need to put the u back in, which is our x plus 2. And so that's our answer. Now we could have just expanded that out and got our derivative that way as well. But usually you're wanting to demonstrate your knowledge of chain rule, product rule, quotient rule. The next one we've got here is a nice little quotient rule. So you've got u on v, where u is equal to 8x to the 4, take away 3x cubed. So then our u dash is going to be equal to 32x cubed minus 9x squared. Our v is x squared, so our v dash is equal to 2x. Now that is our original u over v, so then we've got u dash v minus v dash u over v squared. So then we've just got to pop that back in. So we've got 32x cubed minus 9x squared, and we're multiplying that by x squared. And then we've got 2x outside of, and our u is 8x to the 4 minus 3x cubed. And that is all over v squared, which will be x squared, and then square it. So we can simplify that on the bottom, and that would give us x to the power of 4. We could look if there was any, like we could expand, see if there's any point in doing that to collect like terms. So we would get 32x to the power of 5 minus 9x to the power of 4 minus 16x to the power of 5, and then that would be plus 6x to the power of 4. So then we can simplify that. We've got 3x to the power of 5. We're taking away 16x to the power of 5, so that will be negative 19x to the 5. We've got minus 9x to the 4 plus that, so then minus 3x to the 4 over x to the power of 4 there. Turning the page, we've got one that is a product rule with a chain rule inside it. So looking over here, we've got our u times v, where u is equal to 2x. So u dash is equal to 2. Our v is equal to x plus 1 squared. So what I'm going to make that is a squared, and then say a is equal to x plus 1. So dA on dx is equal to 1. And then dv on dA, so the derivative of v with respect to a, is going to be 2a. And then my dv on dx, so bringing them back together, is going to be 2a times 1, which is just 2a, and pop that a back in, so 2 outside of x plus 1, which we can also call v dash. Then we can put that together because we know that y is equal to u dash v plus v dash u. So we've got 2 outside of, and our v is here, x plus 1 squared, plus v dash is 2 outside of x plus 1, and our u was 2x. So just bringing that down here so that we can simplify it, we've got 2 outside of x plus 1 squared, plus 2 times 2x is 4x outside of x plus 1. Now what we can actually do is take out a common factor of 2 outside of x plus 1, and then in the second bracket we can put the leftover, which will be the x plus 1 plus 4x, and so we get 2 outside of x plus 1, and then here we've got x plus 4x is 5x plus 1. So that's a nice little one that can get put into exams where it's a chain rule inside a product rule. And in the next video, I'm going to look at one where you might be asked to find the gradient at a certain point on the line.